This video provides examples of solved financial ratio problems. I'm your professor, Dr. Stephen Haggard. Too often, students think that financial ratio calculations are really simple because they're usually just one number divided by another number. And so what students expect is for these problems to be, I ask you to calculate a ratio and I give you the two numbers and you simply plug them into an equation. Unfortunately, that is the very bottom level of difficulty for these things, and we've got many levels above that. And so the purpose of this video is to show you some of the different things that can happen in these problems and how to identify them. Also, to show you how to approach these problems, because there's definitely a technique that's best for solving these things. And so that's what I want to do, is I want to prepare you to be able to solve these problems when you see them. Now, you should go back and review my financial analysis presentation before you watch this one. And that will help you because there are some things that I say in there that are important. For example, the equity multiplier is 1 plus the debt to equity ratio, and total assets equal total debt plus total equity. And these will be necessary pieces for you to have in order to be able to solve these more complex problems. A lot of times, students expect every piece of information that they need to solve the problem to be presented in the problem. Sometimes we expect you to actually know stuff, and other times you will need to get from the information in the problem to the item that you need to solve the problem. For instance, I could give you debt to equity ratio when in fact you need the equity multiplier. And so you're going to say 1 plus the debt to equity ratio gives me the equity multiplier. Anyway, so I hope the rest of this video you find it helpful. If you have any questions, as always, please let me know. The biggest problem that I see students encounter in financial ratio problems is how to do algebraic manipulations. Now, many of you had algebra in junior high or high school, but you've probably just forgotten it. And so let's do a quick review. First of all, let's start with an equation. 2a equal 3b plus c. We want to know b, and so we have to get b by itself. But how do we go about doing that? Well, the first thing that we want to do is subtract c from both sides. And when we do, that gives us 2a minus c is equal to 3b plus c minus c. Now note that that's just equal to 3b because the plus c and the minus c cancel each other out. And so now we've almost got b by itself. We just need to divide both sides by 3. Keep in mind, in algebra, as long as you do the same thing to both sides, everything is perfectly fine. And so here we're going to divide both sides by 3. And when we do, on the left-hand side, we get 2a minus c in parentheses, which means we do that part first, divide by 3, and that's equal to 3b over 3. But what is 3 over 3? It's just 1. And so 3b over 3 is the same as 1b over 1, or just b. So now we can just reverse that equation that we've just determined and see that b is equal to parentheses 2a minus c close parentheses divided by 3. And so that's how we get things by them, is through algebraic manipulation. Now let's talk about a general approach to financial ratio problems. The first thing that I do when I read basically any problem in finance is to jump immediately to the question, which is usually at the end of the problem, to determine what you will be calculating. In other words, what are we really looking for? And after I figure that out, then I go back and read through all the information that is given. And as I do that, I'm going to be seeing some information that's going to show me how I need to proceed. There will be the pieces of information that are used in the problem will tell me kind of the method that I need to use to solve it. And sometimes you will actually be given more information than you need. Now, my students get entirely frustrated with me when I include more information than they need. But I tell them this is preferable to the real world situation where we often have less information than what we need to solve the problem. And sometimes you'll have to perform additional processing to make the information that's given usable. In other words, you might need to convert a variable into another variable before you can use it in the problem. Or you might have to do some calculation to arrive at one of the variables that is going to be in your financial ratio equation. And then finally, we're going to select the correct equation to calculate the item requested given the information provided. And sometimes we're going to have to solve the equation for the item that's requested. It won't always be nice and neat where the requested is over on the left-hand side by itself. And sometimes the item requested won't even be a variable in the equation. It will be buried inside one of those variables. In other words, we will have to do something with the answer once we find it. We'll have to do further conversion to it. All of these things make financial problems difficult for students. But don't give up, because we can fix all of these issues with a little hard work and patience. Okay, let's start working some examples. Here in our first example, we have a firm. It has a total asset turnover of 2, an equity multiplier of 4, and an ROE of 20%. Now, if you don't know what these things mean, you need to go back and watch my video on financial ratio analysis. The question is, what is the firm's profit margin? So using the method that I just discussed, what's the first thing that we do? First of all, we look at the question. What is the firm's profit margin? Now, profit margin is typically, if you're lucky, just figured as net income over sales. And so when we go back and read through the question, those would be two things that we would be looking for. However, when we read through this question, we don't have any of that information. So we know we must use a different method to solve this problem. And if I look at this, I start to remember that all of these things that are here are actually part of the DuPont identity, which is ROE is equal to profit margin times total asset turnover times equity multiplier. Now, ROE is what is on the left-hand side by itself in that equation, but that's not what we're trying to calculate, so we're going to have to do some algebraic manipulation to get profit margin by itself. In this case, it's fairly simple. We just divide both sides by the product of total asset turnover and the equity multiplier. And then that gives us profit margin is equal to ROE divided by that product. And so we plug the numbers in. 20% divided by the product of 2 and 4 gives us 2.5%. And so now we know that the profit margin in this example is 2.5%. Let's take a look at another example. Here we have a firm with sales of $10 million per year, a net income of $1 million per year, and total equity of $5 million per year. And the question is, what is the firm's profit margin? Well, profit margin is just net income divided by sales. And we go back and read and see that we are given sales and net income. So those are the only two pieces of information that we need. However, we're also told that this firm has a total equity of $5 million. Do we need that information to solve this problem? No, it's extraneous. It's information you do not need, so you can safely just ignore it. And so we just use our basic equation and throw in our numbers, 1 million in net income divided by 10 million sales. Notice that the dollar signs cancel out and the millions cancel out, and we're left with 0.10. Now that's a decimal. Typically, profit margin people talk about in terms of percentage. And so we need to multiply by 100% to turn that decimal into a percentage. Remember that multiplying by 1 does nothing, and 100% is, in essence, just 1. So this hasn't changed our value at all. It's just put it in a different format. Now on to example 3. In this example, the firm has total asset turnover of 2, a debt-to-equity ratio of 3, and an ROE of 20%. And they want to know what is the firm's profit margin. Once again, profit margin in its simplest state is just net income divided by sales. But we are given neither net income nor sales. And so what do? Well, first of all, we need to look at the information we are given and see how we can use that to calculate the firm's profit margin. We've been given ROE and total asset turnover, which we'll remember from earlier are both part of the DuPont identity along with profit margin. But we see a strange one in here, the debt-to-equity ratio, and they haven't given us total asset turnover. But as I discussed in my financial ratio analysis lecture, the debt-to-equity ratio, you can get to the equity multiplier simply by adding 1. And so if we have got a debt-to-equity ratio of 3, then we know that the total asset turnover must simply be 4, which is 3 plus 1. And so now we can use the algebraic manipulation of the DuPont identity we did earlier to find the profit margin. And once again, the profit margin is 2.5%. And so this is an example of needing to convert or manipulate or transform one of the inputs before you do your calculation. And now for our final example, which is a long one. A firm has net income of $1 million, assets of $10 million, and can grow on internal funds alone at a rate of 5% per year. The question is, what percentage of net income does the firm pay out in dividends? Now notice that the problem is asking for dividend payout ratio, which is simply dividends divided by net income. And notice that we are given the information needed to calculate ROA, which is just net income divided by total assets. We're also given what is called the internal growth rate, which is the fastest rate the firm can grow on new internal equity alone. Now this is one of those situations where you're going to have to know the definition of internal growth rate in order to be able to recognize that that is the formula that you need to use. And so the IGR formula, internal growth rate, includes the plowback ratio, which is simply 1 minus the dividend payout ratio, which is the thing that we're looking for. So what we're going to do is solve for that plowback ratio and then subtract it from 1 in order to get our answer. Continuing with our final example, here we have the formula for internal growth rate. It's ROA times B divided by, open parentheses, 1 minus ROA times B, close parentheses, where B is the plowback ratio. Now remember from order of operations that we're going to do our parentheses first. And inside of those parentheses, we are going to do the multiplication first. And so how I would approach this is to first find the product of ROA times B, and then subtract that from 1. That gives me the denominator. Okay, so we're going to need to solve for B. But B shows up in 2 places here, so it's not going to be easy. So we need to jump into algebraic manipulation mode. And the first thing I'm going to do is multiply that parenthesis by both sides. And when I do that, it's going to cancel out over on the right hand side, leaving me with just ROA times B. My second step is going to be to distribute that internal growth rate to both of the terms inside of the parentheses. This is the distributive property of mathematics. And so now I have IGR minus IGR times ROA times B equal ROA times B. And now my next goal would be to get B on the same side. All the terms that contain B, I want to get them on the same side. And the way I do that is I simply add IGR times ROA times B sides. And when I do that, it's going to go away on one side and show up as positive on the other. It's going to go away because it cancels with the negative. And so then I'm going to reverse the order here. I'm just flopping around the equal sign, which is totally perfectly allowable. And so now on one side I have ROA times B plus IGR times ROA times B is equal to IGR. Now I can pull 1 plus IGR out of that left-hand side term. So this is once again the distributive property, just working in the opposite direction, and say that that's equal to IGR. And now I can divide both sides by 1 plus IGR, and that just leaves me with ROA times B on the left-hand side. We're almost there. We just need to divide both sides by RA, and that will get B by itself because the ROAs on the left-hand side will cancel out. And so what am I left with? I'm left with IGR divide by open parentheses 1 plus IGR close parentheses times ROA close parentheses. Now if you do not remember how to use parentheses in algebra, please go out to YouTube and find a good algebra review. Just remember one thing that we know for sure. You've got to have just as many open parentheses as you do closed parentheses. And here you can see we have 2 of each. Now to conclude our final example, we have B is equal to IGR divide by open parentheses 1 plus IGR close parentheses times ROA close parentheses. And so the first thing we need to do is figure out ROA, because we were not given ROA, but we were given net income and total assets, and it's 1 divided by 10, or 0.10. Now earlier I multiplied something like this in order to turn it into a percentage, but that's because it was the answer that we were looking for, or it would easily convert it into that just by multiplying or dividing by something. But here we're actually going to use this in an equation to perform a calculation. And in those situations, you are always safer to leave it in decimal form. So let's do this. We've got our IGR 0.05, which is 5%, divided by 1 plus IGR, which is 1.05, times 0.10, which is the ROA we just calculated. And when we do all that math, we can see that the plowback ratio, or B, is 0.4762. Remember that the plowback ratio and the dividend payout ratio always add to 1. And so what that means is our dividend payout ratio is simply 1 minus the plowback ratio, or 1 minus 0.4762, is equal to 0.52338, or 52.38%. And in fact, at this point, I could ask you, how much do they pay in annual dividends? And all you would have to do is take that 0.5238 and multiply it by $1 million and find out that these people are paying $523,800 per year in dividends. And so that might be another complication that would get thrown on to the end of a problem like this. I hope through all these examples that you've been able to see that if we follow a methodical process, we can solve these ratios. But you kind of need to have the formulas for the different items somewhat in your head. So when you are reading through the ingredients they will give you, then you can tell what method that you need to use when solving the problem.